Hello to viewers, welcome to my channel Science to Technology. In today's show, Science Thursday, we're going to talk about oil refinement process. Basically, what the heck is an oil refinery? So let's dive deep into it. Now let's be very clear. Crude oil is what we classify as black gold, meaning lifeblood of modern civilization, as in there is everything else and then there is crude oil. The most important liquid there is on this planet in this era. Flat out, and it is of what we classify as national importance. Heck, I'm not even joking. The reserve of this puppy is classified as strategic reserve, national reserve. It is important, and it is so important that source and quality does not matter. Meaning, for national security, if let's just say you have a source that is just not good enough, does not matter. You're gonna milk that puppy. So same goes with quality and quantity and source. It does not matter which country is selling you. It's like it is so important. It does not matter. And it's core of many war and power games in the globe, which again, duh. So like Russia-Ukraine one, how do you think Russia is funding it? Gas. How do you think Maduro was taken out of the equation? Oil. So, and people say, no, oh, that oil is dirty. Does not matter. Oil is such a high value target, such high value commodity. You will redo your whole refinery in order to make sure you can milk it. Like flat out. There is no discussion about this. So it is one of those things that we classify as matter above all, meaning if it's a country is healthy and just growing and all that jazz is, that means this part is taken care of. Meaning if this part is not sorted, country cannot be healthy or stable. Does not matter. Even I'm talking as small European nation. If they are stable, looks fine, that means they have this part sorted. It could be an island nation like let's say Sri Lanka. Yeah, if they do not have oil part sorted, boom. So fundamentally, crude oil is important. So this, I'm reasonably sure all of you in your school have studied this, what we call fractional distillation. So crude oil, whenever you're talking crude oil, what does it mean? That simply means it's a mixture of hydrocarbons, meaning it has multiple ratios of hydrocarbon, meaning it could have something as light as methane, like C1NH4. So it could have something as light as methane or something as bonkers as like C20 to C70, like almost char. Tar, sorry, I'm saying tar. So it's a mixture of that. And the ratio is, who knows? So each hydrocarbon chain, thankfully, has what we call specific boiling point. Unfortunately, it's not very far apart, but it is far apart enough, meaning you can start heating this puppy up. Like you're going to heat it up to 1000 degrees Celsius or even more, depending on what you want to do or how dirty or clean it is. So you will start to get your fuel oil, basically the ugliest oil known to man, but again is the reason why we have shipping, because all the ship runs on it. So that would be at 600 degrees Celsius. That puppy starts to condense. That's thinking. That puppy starts to condense at C600, 600 degrees Celsius. But that's heavy crude oil, as in like C20 to C60. Then you start to go up like C20 to C50 range, which is lubrication oil. All the lubricants are made from that puppy. Then you go to diesel, which is 270 degrees Celsius, C14 to C20. Then you go up a bit more, 170 degrees. Paraffin oil, it generally is not directly used. It's kerosene variant, so we mix it and spice it up. So that will give you C10 to C16, to 120 degrees Celsius, that's gasoline, C8 to C10 kind of series. And then you have naphtha, which is C5 to C9, naphtha, and then you have gases. Gases are the easiest thing to separate, but everything else is a hell lot of a hassle, so to say. And fractionation allows you to do what we call bulk separation, meaning you take your crude oil, you digest it through this puppy, and then you have rough material. The gap between basically fuel oil and gas would be absolute. There will not be any contamination in fuel, basically fuel oil, and any contamination in the, but things that are in these two regions, they will be contaminated as hell. Meaning your gasoline will have way too much mixture of diesel will have way too much mixture of paraffin oil. So this sort of creates a scenario. This is just bulk separation, not final separation. And again, this column is designed based on what is your input, and temperature is maintained based on what is your input. Crude oil, depending. So if you're like, okay, I'm getting Venezuelan crude, this will be adjusted for that. I'm getting Saudi Arabian crude, you will adjust it. I'm getting Russian oil, you will adjust according to it. So School generally stops that, like you get what you want. Yeah, no, this is just a rough separation. So it has way too much overlapping boiling point with too many things. So you will not get what we classify as pure. It's gonna be useless. Basically, you cannot take, oh, I got the diesel, I'm gonna take the diesel and put in a diesel engine. It might work, but it might go boom. So yeah, that's not useful. It needs further processing. This is step one. Super easy to analyze where the heck it's happening, because it will be generally one of the tallest tower with way too much pipe, and it would be way too skinny. You can just look at it as like, yep, very high hit probability. If you want to look for tall, slim tower which has way too much pipe, this is what you're looking at. So that's the distillation column, step one. After that, we do multi-stage. Basically, without multi-stage fractionation, things cannot be used. Which things cannot be used? Kerosene will not be useful. Jet fuel, forget about it. Diesel, naphtha, yeah, these things require multi-stage processing. And sometimes, how many stages? That depends on the contamination and how close the boiling points are. So you could be looking at 3, 4, or even more stages. For example, this is an example of butane and peptane. So what do you think the mixture ratio is? 50-50%. So it's flat out useless. So they have to boil it up 50% to 50%, 185 degree Fahrenheit. Then they will separate it. So 50-50% goes in, it becomes 65-35%. Slow boil it again. That gives you basically 75 to 25%, 165 degree Fahrenheit. Then you get 85% butane to 50% peptane. Now it's useful. And again, you might do it more if you need very high quality. So I'll give you a very simple explanation. All jet fuel is kerosene. Not all kerosene is jet fuel. Basically, you take kerosene, you go through this process and you get good kerosene, and then you do that step again multiple times to get jet propellant, which is JA1. So kerosene, of course, kerosene have to be made sure that it's not mixed with some other hydrocarbons. So you filter it out first, and then you take kerosene and you like really refine it. Then you get jet fuel. Same goes with diesel and naphtha. So it is a very hassle, and that's why the refineries are huge. The distillation column is not that big, but having 5-6 stages of these, yeah, it starts to add up. Like the surface area, the volume, these starts to eat up. And be mindful, you might have to do it for multiple products. So yeah. And how do you achieve it? Well, you have generally two toolkit. One toolkit is vacuum distillation. Another is steam distillation. Steam basically could act as a catalyst. It could act as a main agent, or it could be just be as suppressant, basically just suppressing the pressure. So depending what you are doing, how you are doing it, that goes into that. So these are the tool that gives you the base product. Now, hopefully, after you are doing all this stage, what we call multi-stage distillation, you should have a product that, okay, if I take this diesel and I put in my diesel engine, it should run. It just won't run for long, but it should run. So, and these things are hungry in terms of energy consumption. They are bonkers and they are huge. Like distillation tower is tall. These things are huge. And not to mention, it's Control C, Control V, Control C, Control V, Control C, Control V. A lot of them, like you have to have a lot of it. So these are large unit, like surface area wise, huge. So at this, now you have a feedstock that is actually what you actually think of. Now there is a big problem with this, is like output of crude oil is not a controllable factor, meaning you get crude oil the end. Like if India gets a crude oil from Russia or gets from OPEC, it does not matter. Like we get it the end. If we cannot say, hey, return this batch, we want more diesel in it. Yeah, that does not work. So it's an uncontrollable factor. You get it, the end. So we generally have two choices at that point in time. One, what if you are getting way too much heavy puppy, like large hydrocarbon, and you're not happy with that? You want lightweight puppy. So you crack it, which we call hydro cracking, meaning generally you use hydrogen and then you put a catalyst, special sauce, and then you break large hydrocarbon chain into smaller. For example, let's just say you got too much fuel oil and your country drinks diesel like there is no tomorrow, but you do not have enough of a navy, enough of a sea asset to consume fuel oil. At that point in time, you're gonna do this hydrocracking to shift heavy hydrocarbon into lighter hydrocarbon. But what if you get it reverse? Basically, you're getting too much light hydrocarbon and you need heavy puppies. So at that point in time, you can stitch hydrocarbon chain into small one. So stitching, again, it does not have a clear-cut name. So alkalization using acid and stuff is one way of stitching it. Another is carbon-carbon bonding via catalytic polymerization. So that's another puppy that helps you to cook what you want. So either you can stitch things or you can break things apart. And that's how you get the final ratio that country needs. Basically, country will control the throttle of it. For example, if let's just say naval assets are consuming too much, okay, fuel oil will not be touched. If naval assets are like calm, it's like, okay, convert those things to other things. So there's a lot of back and forth between government, strategic reserve, and all the stuff. So this is the conversion step. This is how all modern oil refineries work. Now we come to the final stage, which is quality control. At this point in time, you just have a raw material, which again, thankfully is a material, but still raw. Generally, you do not get naked petrol and diesel because it would be too dirty and too destructive. So we send it through what we call hydrogen treating basically. You take your feedstock, heat that puppy up, dump GG amounts of hydrogen into it and put it and cook it in a pressure cooker for very high temperature, like 300 to 400 degrees Celsius at 30 to 330 bars. It's like GG amount of pressure cooker. Why? Well, hydrogen has very high reactivity, meaning it reacts the hell out of with everything. For example, it will react with sulfur. And be mindful, there is so much sulfur in crude oil. Many refineries literally sell you sulfur because it's getting so much of it. So sulfur is, oh, by the way, it also reacts with a nitrogen that is infused into it. So ammonia output is also there. And if it's a good, what you call oil refinery, generally it will have output for all of this product. They will not just waste it. Or they will figure out how to use it on site. So if like, let's just say they have ammonia and they're like not enough demand for it, they might just use it as a, heating fuel. So you have hydrogen, sulfide, ammonia, all of that. And then you'll get a system that is actually safe enough where it does not have too much sulfur that will destroy your engine. So, this is step one. This will be done multiple times for jet propellant. Jet propellant has to go through like a really rigorous cleaning stage. So hydro treating. And then after this, you have a material that is ready for its clothes, so to say. So you generally don't get naked fuels. So you get additives added to it. For example, fuel stabilizer, corrosion inhibitor, most important, detergent. There's a lot of detergent in your fuel, so your fuel injector does not self-destruct. And again, we used to add lead because we were stupid, but we learned, we removed lead. We have other stuff, so like ethanol and all that. So these will be done after this stage. So, and then final QC will be done. Every country generally has an emission standard. Now, we think about emission standard in terms of engine because that's what you and I are dealing with. Oh, I'm buying this car, this has this emission. Yeah, that's just one step. Fuel is also changed. But again, you and I do not have to worry about it. That's a oil corporation's headache, and they generally are told in advance, years in advance, that we're going to switch it. You have enough time, they start switching day one. Basically, if government comes to them, it's like, okay, we're going to go to BS6 fuel standard. They will start to switch the moment they hear the news. And they will tune it, fine tune it, refine it, standardize the process, then replicate it in other refineries. So they will start working on it day one. So it takes time to basically make sure your fuel meets the emission standards. Again, you have to remove sulfur, ammonia, and all that jazz. So that is it. And storage and distribution is the final step. Now, storage is a bit messy because again, these additives, while they do make your lightweight engine work very amazingly well, they also make it very fragile. Meaning, if you took up petrol and you're like, okay, I'm going to store it for 6 months. Yeah, you do not have a petrol, you have a gunk. Many of those additives are only stable for 6 months. So that's why many petrol pumps will sell you additives that are stabilizers for those additives, so it can last long enough. But diesels are a bit more stable, but again, even those have upper limit, especially with your fuel injectors. So whenever you have to store it and you're like, okay, this is refined products that we have to store for long term, they will not put additives into it, or they might make sure the environment is controlled, as in not only the temperature is controlled, but also there is no oxygen. As in, they might flood it with argon, they might flood it with carbon dioxide, depending on the requirement and how sensitive those are. Basically, if you remove oxygen, these things can last long enough time. Or you might as well not add an additive, because adding additives is not that difficult of a process. So they might look, okay, let's store this naked fuel, and when we need that emergency reserve, we're gonna dump it. So that's one step. Second, you store crude oil itself. Why? Well, here's the deal. Refineries have this problem. It's very fine-tuned machinery. They need constant flow. They do not turn off. There is no holiday, there is nothing. They do not turn off. And they have to be like this. Otherwise, if shutdown happens unplanned, yeah, good luck trying to get them back online. And again, it's a national stuff. We drink too much fuels for refineries to be offline. So what happens if a Strait of Hormuz starts to go kaboom? Strategic oil reserve will start to be utilized to make sure refineries are fed for at least short duration. So a country could have reserves for a few days to a month to half a year. That's the maximum I've even heard of. Like, I have not seen anyone who's trying to push more than half of a year. Or sometimes you could store gas. Europeans do too much gas where they're like, okay, we're going to store it for half a year. And again, you must have seen the news where USA and Israel are going boom boom with Iran, and Iran, because they can't deal with Israel or USA, so they're like, okay, we're gonna boom everything else. So Saudi Arabia's main gas terminal got boomed, and the moment that happened, natural gas price went kaput. So at that point in time, this sort of things will help us a lot. At that time, basically, the reason why your bank balance does not evaporate instantaneously is these reserves. They allow enough of a buffer time where hopefully, finally, Israel or USA might finally figure out, okay, they should have only 2,000 missiles. Like, come on, delete those missiles. Because again, whole world is getting affected by that. And these reserves are just reserves. They are not like source. So quality control and strategic reserve. And again, how much you store of what? Like, basically, if a country is smart, they will store far more diesel than they will store basically gasoline. Because again, gasoline sounds important. It's not. Diesel, yeah, your country dies if you do not have diesel. So diesels are much higher priority. So depending on your nation's budget, like again, if you are in winter place area, basically where you have freezing temperature, natural gas is used for heating, you will prioritize that. So this is the quality control, balancing, all that politics goes into this. So this was just an overview and a look of how things go and play into oil refineries, why the heck those buildings are huge. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike. Press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free. And as always, thanks for watching.